Okay, we are in a discussion of AWS solution architect, right? Um, Today we're going to discuss about VPC, Amazon VPC and network architecture, right? VPC is basically the basic infrastructure in the Amazon cloud. Many resources instances, virtual computers, right? And a lot of systems, we're going to put it in VPC, right? There are some services they don't need VPC, but mainly most of services we put them into VPC. So VPC is linked to a lot of services, right? So Amazon VPC, a private isolated section of AWS where you launch resources, right? So VPC is a regional service. So if you create a VPC, you have to select a region, right, to put in a VPC. There are multiple reasons you can have when you are selecting a region, or maybe it's closer to you, right? So closer to you to get your sort of less latency closer to user, or it can be sort of compliance. So your data cannot be put into a different region, so that you have to select your region according to data compliance policies, sort of things we have to consider when you're selecting a region for VPC, right? Um, this is region scoped service, right? Uh, VPC, you got subnets. The subnets are in availability zone specific. That means subnets are in data centers in the region, right? And then you have to define IP address range, CIDR blocks, similar in sort of similar to Azure, and they support IP version 4 and version 6 IP addresses, and then you can connect on premises via a VPN or AWS Direct Connect feature, right? And when you're logging into your portal, right? Yeah, you got if you can see, you can see the default VPCs automatically created one of the VPC in every region, right? And then custom VPC you just have to create manually. So you just when you log in to the portal, just created for you sort of a VPC, default VPC plus some of the services, sort of subnets, and then internet gateways and one or two public private subnets. So that being created for you if you want to do something like a test, right? So public subnet is created, yes, with the internet gateway. In if you create a manual, it doesn't create anything, so you have to define them. But that's option VPC and more. When you're creating VPC, you can create a pure VPC, or you can create a VPC and more. In a VPC and more, you can select more options like subnets, internet gateways, net gateways, as well as some security groups. So you can create some sort of more things in using that. we'll have a look one of the day when we creating that. I will show you guys, right? So use cases. So we usually can do testing. So all what I'm doing in the testing environment, I create these testing resources. But if you want to create production workloads, you need to create a custom VPC, and then carefully you have to uh, create all other resources, whatever only needed. As you know, when you're creating resources, probably it's going to cost you money. So, in the case of production workload, you are considering so many things like security and cost. So, you just need to make sure you create resources only needed for you, for your environment, right? And in a VPC, you have subnets, right? Two type of subnet you got in AWS VPC. So they are public and private subnet. So public subnet, uh, you has a route to internet gateway, right? Uh, and private subnet, there's no direct internet access, right? So to make sure you have a multi availability zone for high availability, right? Um, Briefly, if I explain internet gateway versus net gateway, right? Internet gateway allows inbound and outbound access in a public subnet, and net gateway only allow outbound access, right? What you need to remember is net gateway is per availability zone, right? But internet gateway is region wide. So internet gateway is directly connected to the VPC as a region wide. If you have a few different subnets, public subnet, you can go through internet gateways, right? And the other, some of the other options are VPC peering between two VNet, so VPCs in different regions. So sometimes I might tell Azure or VNet. Uh, Sometimes it's come into my mind because I have been doing these other series with the Azure VNet as well. So we are here talking about AWS. So just discard maybe if I tell VNet, I'm telling VNet is VPC here. So we call VPC, right? So VPC peering connecting two VPCs, that is similar like in Azure. So the non-transitive, A connected to B connected to C. That doesn't mean A connected to C. So A, B. So if you need A to C, just need to create a VPC connection between A and C. It's not going to work A, B, B, C connection. That says non-transitive. So we got VPC endpoints. These endpoints help you to security and less cost because VPC endpoints, you create them and connect to services in Azure locally traffic. You can use the local traffic, right? So they have two type of VPC endpoints. One is called interface endpoints, right? Uses ENI, more services, right? And then gateway endpoint. The gateway endpoint for S3 and DynamoDB, right? That's the two major endpoints. We're going to talk about them with some of details in the next so later in this video. So in this picture, you can see AWS cloud, and then you created a one VPC, right? This VPC, let's see, we created in a one of the region VPC. So you create one of the internet gateway. So internet gateway is region wide. So this internet gateway you can use for public subnet in availability zone 1 and public subnet in availability zone 2. If you have six availability zones, that means six different data centers here, you can use this internet gateway as long as that availability zone is public subnet and it's inside this region. But net gateway is per availability zone. See that in availability zone 1, you got a net gateway, and availability zone 2, you got a net gateway. So you can't use net gateway in availability zone 1 for private subnet in availability zone 2. So you have to each subnet, you need to make sure you have a different net gateway to outbound traffic. So net gateway only allow for outbound traffic, right? Um, so actually the net gateway is connected to private subnet, but net gateway will be in a public subnet of that availability zone, right? So normally it's in a public subnet, so it need to be placed in a public subnet to get them access, right? So the other important aspect is security group and network access control list in AWS VPCs, right? And we have these. We're going to talk about security groups and network ACLs. Before I'm explaining this graph, I'm just going to go to next slide and come back. Uh, so, like in Azure, you have NSGs, network security groups. Here, you got two type of different security controlling mechanism here in Azure. Sorry, in AWS, right? So they called security groups, and then the other one is called network ACLs, right? So here is an introduction to stateful and stateless filtering. So we just need to understand what is the meaning of stateful and stateless, right? That's all depend on how their behavior, right? So stateful filtering, right? See, stateful filtering we called in security groups in the AWS, right? So they remember previous decisions for traffic flows, right? Allow return traffic automatically. Let's say you want to access something outside, right? And if anything returns from that traffic, it will allow you to come back, right? They only allow rules, right? There's no explicit denial rules, right? Only allow rules. If you allow something in that the returning traffic also allowed, these ones operate at instance level, so they can only be applied into a instance level, EC2 into network cards. Because of A only use allow rules. If you allow something to go out and return traffic is coming back, allowed as well, right? And secondly, the stateless filtering is we called network access control list, ACLs. Um, Stateless means these evaluate each packet independently, right? Requires explicit rules for both inbound and outbound. You have to create both inbound and outbound rule, right? Supports both allow and deny rules. So that can be used allow and deny rules. So operates at subnet level. So that will use in subnet level. So this network ACLs you can't use in a instance level. So that's we just need to understand, right? See that so stateful filtering is used only for allow traffic, and then stateless filtering is each packet independently checking. So if something we allow go out, you need to let it to come back with another rule, right? So let's go back and have a look at previous graph, what it says. Let's have a look what it says. So security groups versus network ACLs in AWS VPC. So in the blue color, we use security groups, right? And then red color, we use network ACLs. Comparison categories. Let's go and have a look what it is. All right. So security groups stateful return traffic is automatically allowed, right? So this one, that is instance level, right? Instance level. Okay, let's go this one. Operate at subnet level, controlling traffic in, out of a subnet, right? Here, security group support only allow rules implicitly at the end, right? They only use allow rules, right? Rule types, allow rules. Um, Rules are evaluated in numerical order, lowest first, right? In evaluation order, rules are in ACLs, they are evaluated in numerical order. So if you have um, um, just something in low order rule, that will evaluated first, and something in a higher number will do it after the lower numbers, right? All right, so that's a smaller graph there. So this one, right? So this probably explain client server communication, right? Stateful filter tracks connection state to allow bidirectional traffic go for established connection. See that this one stateful filter. So if anything connected, uh, that will allow return traffic from here, right? Um, let's have a look at this one. What it says, this graph, right? This graph is saying stateful versus stateless filtering in AWS VPC, right? Security groups stateful and network ACL is stateless are the primary filtering mechanism in plus VPC, right? So packet processing. Let's have a look. Examine packet in the context of previous packets. So in a stateful situation, packet in previous packets, so return packets is allowed. Remember the connection is state and attribute. So it remember the connection state. So this one is the packet processing. Examine the packet in concept of previous packets, right? And this one require less memory and yet it doesn't track connection, right? Resource usage less in a stateless connection. No stale tables to sync, simply HA configurations, right? No state tables to sync, simpler HA configurations for high availability. Um, can scale more easily without connection state limits. So the scalability, there's no problem number of rules filtering in that case, right? So security groups used in EC2 security groups protect specific resources. So this one is protecting instances. This one is protecting a broader range uh, subnet level. All right. Um, so let's have a quick look. The best practice in the how do you use effectively network ACLs and security group best practice. So as we discussed, security group I stay full, only used for allow connection, and it remembers um, allow whatever previous connection state full operates network ACLs, right? They operate in the subnet level, right? So let's have a look at the point form details. Network ACL is stateless firewall that operates at subnet level, applies to all instances in associated subnets. So anything in the subnet will be applied in these rules. Configure separate rules for inbound and outbound. You need to configure separate rule for inbound traffic and outbound traffic, right? Process rules in numerical order. So you got something like 100, 200, 300, 400. So it will process in the order from lowest number to highest number, like process 100 first and 200 second, something like that. So stateful firewall operating at instances level, right? Allow rules only. There's only allow rules, right? Deny by default because if something created inside to out, that's the only things allowing, right? Evaluated collectively before allowing traffic, right? That will available so evaluated according to whatever they have remembered that connection, right? Reference of the security group as source, right? So so here, right? See that network ACLs in the subnet boundary. So network ACL evaluates packets based on no ordered rule, right? Let's say first rule is uh, HTTP is allowed, right? And then rule two allowed SSH, right? And then rule three is deny FTP, right? And then rule four is deny all, right? So according to this one, right, it's evaluated packets are based on ordered row, right? And they are evaluating inbound and outbound traffic of both of them, right? Best practice, right? Good to have a look. So network ACS used as perimeter defense, right? So normally, so that's depend whole subnet, whatever inside in whole subnet. If you don't need services, you don't need it to allow them, right? So it will collectively, I mean, all together, it will protect all the instances inside the network. So block high risk CIDR blocks, right? Keep default root for maintenance access, right? And you can keep something really necessary, and then you can disable, everything else, right? Uh, Security groups follow the principle of a least privilege, right? And use reference group over IPs, right? Implement for granular control, right? It's only a sort of you only need to go outside. You can use them for if you need a more granular control, right? Correct. We going to now we had a actually we had a sort of more digged deep into a security group, and I think it's already gone for about 26 minutes in this video. I'm probably going to end and then continue this one with the second video. So probably going to go more timing. So I think I'm going to finish this video for today, and we'll going to see you guys from next video. Until then, thank you very much.